action of heat on salts. We want to find out what happens when salts are burnt, when they undergo combustion or burning. What are the products formed? It is important to know the products formed when carbonates are heated, when nitrates are heated, and when sulfates are heated. So we want to begin with our salt group number 1, that is the carbonates. We want to find out what happens when the carbonates are heated. So I want to put into your attention that pure carbonates of potassium and sodium, pure carbonates of potassium and sodium are not affected by heat. It is important to know that when the carbonates of potassium, carbonates of sodium, when heated, they do not decompose because they cannot, or because they are stable. In short, is that this is because they are very stable. They are very stable. But if they contain water of crystallization, that is what is lost. So we are saying that potassium carbonate and sodium carbonate are not affected by heat. You cannot heat them. When you heat, there is no reaction. They cannot decompose. But the other metals decompose on heating, forming the metal oxide and carbon 4 oxide gas. So the rest of the metals, they decompose when they are heated and they form the metal oxide and carbon 4 oxide. So generally, metal carbonate and then you heat, they form metal oxide plus carbon 4. So when you heat a metal carbonate, it decomposes to form metal oxide and carbon 4 oxide gas. You know how to test for carbon 4 gas? When this gas is bubbled through calcium hydroxide or lime water, a white precipitate is formed, and that is how we test for carbon 4 oxide gas. Let me give you one example of a carbonate. So for example, if we have calcium carbonate, which is a solid, when you heat this, you form calcium oxide plus carbon 4 oxide. This is a gas and this one is a solid. So remember, all oxides are solids. This is a gas. All carbonates are solids, are insoluble, except that of sodium, potassium and sodium. These one are soluble, they dissolve. The rest, so these are solids. So take any example, even if it is zinc carbonate, when you heat, zinc oxide plus carbon 4 gas, this one is a solid. So this is the reaction. So most metals, they react, and these are the products formed when they react. There is an exception. We want to look at the exception. Exception is ammonium carbonate. When ammonium carbonate is heated, The product formed are not the same as the one formed when metal carbonates are heated. So when you heat this, ammonia gas plus carbon 4 oxide gas plus steam are formed. So with an exception of ammonium carbonate decomposes on heating to form ammonia gas, carbon 4 oxide and steam. But the rest, they will form what we have said. Next one, we want to look at metal hydrogen carbonates. You should know that metals higher in the reactivity, the carbonates, or we are saying this, that hydrogen carbonates of metals in high, or metals high in the reactivity series decompose on heating to form metal carbonates, carbon 4 oxide and steam, in fact water and water. Example, sodium hydrogen carbonate. When heated, it forms sodium carbonate plus carbon 4 plus water. If it is potassium, it will behave the same. Potassium hydrogen carbonate. When you heat, it forms potassium carbonate. It forms potassium plus CO2 plus water. Liquid, gas. This is a solid, a gas, liquid. So that's how they decompose on heating. Let us look at nitrates. Effect of heat on nitrates. Nitrates depends on the reactivity series also. Metals, or the nitrates of metals higher in the reactivity series like potassium and sodium, when heated, they form two products. This one will form potassium nitrite plus oxygen, sodium nitrite plus oxygen. But the rest from calcium, magnesium, aluminum, zinc, iron, lead, copper, up to copper here, they will form three products. They will form the metal oxide. They will form the metal oxide, nitrogen 4 gas, and oxygen. Those metals lower in the reactivity series like mercury, silver, and gold, they will form the respective metals, nitrogen 4 oxide and oxygen gas. So effect of heat on the nitrates depends where the metal is placed in the reactivity series. So potassium nitrate, when heated, it decomposes to form potassium nitrite. This one is nitrite. Potassium nitrite plus oxygen. Also sodium nitrate will decompose on heating to form sodium nitrite plus oxygen. So these are the metals higher in the reactivity series. That is what this is how they form when they are, these are the products formed when they are heated. So when we come down the reactivity series to calcium, magnesium, zinc, and the rest, the nitrates, for example, calcium nitrate, when heated, it forms the oxide. It will form calcium oxide plus nitrogen 4 plus oxygen gas. This one is a solid, gas. So the magnesium nitrate will form magnesium nitrate. This one, there is 2 here, sorry. This one will form 2 here. So magnesium nitrate, therefore we need to balance the equation by putting 2 here, 2 here, 4 here. We balance like that. So magnesium nitrate will decompose on heating to form magnesium oxide plus 4 nitrogen. Here there is 2, there is 2 there, plus oxygen. So that's how they will form. Zinc nitrate will decompose in a similar manner. Now, another thing I want you to have in mind here is the color of the oxides. The color of the oxides, very important. The color of the oxides is very important to note. Zinc nitrate, when heated, it decomposes to form zinc oxide, nitrogen 4 oxide, and oxygen gas. So we are interested to know the colors of the zinc oxide. Remember, zinc nitrate is also white. These are white. Zinc oxide, the color of zinc oxide when hot, it is important for you to note. When hot, it is yellow. When hot. So zinc oxide is yellow in color when hot, and then white when cold. Very important to note. Always you know this one is brown gas. Nitrogen 4 is a brown gas, and the oxygen is colorless. Very important. I want to write those oxides that has a specific color only, because it's going to be helpful when you are given a flow chart. Lead nitrate decompose on heating to form lead oxide, nitrogen 4, and oxygen. I'm interested to know the color of lead oxide. This one is white. So lead oxide is orange when hot, and it is yellow when cold. Very important to note. You will see the importance of what you are doing. And the last one I want you to give it the color is the copper. Copper 2 oxide is black. It's actually black. So when we heat copper nitrate, we will form copper oxide plus 4 nitrogen. Here is 2 plus oxygen, and here is 2. So this one is black. So it is important to know the colors of the oxides that are formed. The last one is the nitrates of the metals below in the reactivity series. For example, silver nitrate. Silver is valence 1. So when heated, instead of forming the oxide, they form the metal itself. So this one will decompose to form silver plus nitrogen 4 plus oxygen. There is 2 here. This one is a solid gas. This one is a solid. Mercury and gold will do the same. So let me write for you for mercury. Mercury is Hg nitrate. Mercury is valence 2. So when heated, it forms mercury. Heat, it decomposes to form mercury plus nitrogen 4 plus oxygen gas. It is important to know that Metals below down there in the reactivity series, when they decompose, they form their respective metal and nitrogen for oxygen. They are only three actually. It is silver, mercury, and gold. Gold is Au. So you should know that. Let us look at the examples or the application of what we have learned on the effect of heat on nitrates, carbonates, and hydrogen carbonates. We have a question here that says, the products formed by action of heat on nitrates A, B, and C are as shown below. So this is a nitrate, the product formed. Nitrate A, when heated, it forms a metal oxide, nitrogen 4, and oxygen. Nitrate P formed a metal nitrite and oxygen. Nitrate C forms the metal nitrogen 4 oxide and oxygen. Arrange the metals in order of reactivity, starting with the most reactive. Now, how will you know the most reactive metal? We said that nitrates of metals higher in the reactivity series, when heated, they form the metal nitrate plus oxygen. Therefore, B could be sodium, potassium, or sodium. Therefore, these are the most reactive. And then we know that metals of the least reactive metals like silver nitrate, silver, mercury, and gold nitrate, when heated, they form the metal nitrogen and oxygen, nitrogen 4 oxide and oxygen. Therefore, now we know that C could be either mercury, could be Au, could be even silver Ag, right? Metal oxide, now here, these are the zinc nitrate, the zinc, the copper, the lead, all of this. So how will you now we want to arrange them in the reactivity. So this one is the most reactive, so we start with the B, followed by A, and then the least reactive is C, and that's how you apply what we have learned. Give the chemical formula of the carbonate of B. So B, we have the carbonates of B. We can use either sodium or potassium. So the carbonate of B, so it will be B carbonate. Put it to here, or we can give one of them K2 carbonate or Na2 carbonate. So N of them. Let's look at the other one. The product formed by action of heat on carbonates A, B, and C are shown. Carbonate A, metal oxide plus carbon 4 oxide. Carbonate C, no product formed. And then B, ammonia. This, arrange the metals in the order of activity. We know that carbonates of potassium, carbonates of sodium are not affected by heat. Therefore, no product is going to be formed. Therefore, C could be either this or this. Metal oxide, these are the rest of the metals, zinc, lead, all of those, they will give this. And then this one, the exception I told you about, this is so B is likely to be ammonium carbonate, because it is ammonium carbonate which produce ammonia, carbon 4 oxide, and carbon 4 oxide and steam. So we are asked to arrange metals. So the only metals we have here is A and C. So therefore, the most reactive is C, followed by A. This is not a metal. Which of the carbonate is soluble in water? Carbonate that is soluble in water. We know that all carbonates are insoluble except those of potassium, sodium, and ammonium carbonate, and that of ammonia. So which of the carbonates are soluble in water? So the carbonates of B and C are soluble in water. B is ammonium carbonate, soluble. C is either potassium or sodium carbonate, which are soluble in water. That's how we use this concept of the heat, the effect of heat on salts to answer these questions. Here is another application of what we have learned on the effect of heat on salts. We have been given this flow chart. We have here gas Q, solid, yellow when hot, white when cold. Solid M. When solid M is heated, it forms solid R and gas Q. But solid R that is formed is yellow when hot. That's why I told you that when you are heating nitrates, make sure you know the product formed and the color when hot and when cold. We are going to use that to determine the solid M. Solid M, when added to nitric hydrochloric acid, it forms carbon 4, water, and the solution P. So what is solid M? Because this is what we should begin with. Which one could be solid M? How do you know? We begin here. The salt that is formed when solid M is heated, solid R is yellow when hot, white when cold. What was that? So we know this one R definitely is zinc oxide, because zinc oxide is yellow when hot and white when cold. So even how we know R? Because of the colors. It is from the colors we have identified that solid R is zinc oxide. Now we can go back. So this one was heated to give us zinc oxide and gas Q. But when we go here, we see that this one, when it reacted with HCl, it gives out carbon 4 oxide. So there is no way a nitrate can give carbon 4 oxide. Therefore, definitely M solid is likely to be zinc carbonate. So that zinc carbonate, when heated, it gives out zinc oxide and CO2. Right? So because of these colors, we have known that solid R is likely to be zinc oxide, and we have used that to go back. Carbon 4 oxide is produced when this solid M is reacting with HCl, then it means this must be a carbonate or hydrogen carbonate. But an hydrogen carbonate, when heated, it gives metal carbonate. So this one cannot be a metal carbonate. So that's why we have not said this one could be an hydrogen carbonate. So let us go to the right. So now we have zinc carbonate. When it reacted with the HCl, this and solution P will be zinc chloride, because this one. So when you write a reaction is zinc carbonate plus HCl, it will give you water, carbon 4, and zinc chloride. Name solid M, zinc carbonate. You are not likely to score a mark by writing this, because you have been told name. When naming, you must give the name. But if you ask it, identify solid M. To identify, you can use the chemical formula. For this one, it is the name. So the name is zinc carbonate. The name. Solution B. Solution P is zinc chloride. The name chloride. Gas Q. Gas Q is carbon 4 oxide. Solid R, zinc oxide. Very good. Write the chemical equation for the reaction is step 1. Step 1 is heating, therefore zinc carbonate. You heat, you form zinc oxide plus CO2. Step 2, that is neutralization reaction. So zinc carbonate solid plus HCl, we are going to form zinc chloride plus water plus CO2. O2, which is a gas, liquid, aqueous, solid. So 2 is here, we balance by writing 2 here, and that is balanced. State the type of reaction in step 2. Step 2, we are adding this is a base, so it is a neutralization reaction. It is a neutralization reaction. Another question that is applying the concept we have learned is here. So we have been given a flowchart diagram, a diagram here. So we want to identify what's happening. This one should be not red brown but orange when hot. So we may not be able to know solution V, we may not be able to know solid N, we cannot know, but we have here this gas, brown gas. The only gas that we have that is brown is nitrogen 4. You should know that nitrogen 4 is known to be brown. That one you know. We are sure that this one could be a nitrate, because when you hit a nitrate, it is the nitrate that will give you nitrogen 4 oxide. That's another thing that will help you to identify solid N. But more important, when solid N is heated, it produces solid U. What is the color of solid U? Solid U is orange when hot, yellow when cold. What was that we talked about? So solid U is lead oxide. Go and look at lead oxide. What are the colors of lead oxide when hot and when cold? When hot, it is orange. When cold, it is yellow. That's what we said. Therefore, this is how we apply what we have learned. So we have said now this is lead oxide. So obviously, if this is lead oxide, then it must have come from lead nitrate. Therefore, this one is lead nitrate. Why do we say this one is red nitrate? When you hit a red nitrate, a nitrate is the one which gives you oxygen, gives you brown gas, which is nitrogen 4, and then the oxide, the metal oxide. So now we know that solid N is lead nitrate. We can now go back. When you add water to lead nitrate, you form a solution of lead nitrate aqueous. To aqueous solution. Now we have an aqueous solution of lead, which is solution V, and then solution V added few drops of sodium sulfate, and then a white precipitate is formed and a colorless solution is formed. That is now the precipitation reaction. Now identify brown gas N. Because we are told to identify, now here you can use the chemical simple, because it is not naming it. Now you can use either the word, so nitrogen 4 oxide, or this, only this, because to identify there is no limitation of whether you are going to name or not. Solid U is lead oxide. Write the word down the equation for the reaction takes place when this is heated, when solid N is heated. So that is lead nitrate. You heat that, you form lead oxide, which is orange when hot, yellow when cold, plus nitrogen for the only gas, which is brown, and then plus oxygen gas. You need to balance the equation. 2, 2, 4. Gas, solid, and that's now a balanced with status equation. Name the cation and the anion present in solid N. The cation is lead, the anion is nitrate. Therefore, the cation is 2 positive, and then the nitrate is NO3 minus. That is the anion and the cation. Write the ionic equation that leads to the formation of the white precipitate. So the white precipitate is formed here. Lead nitrate is reacting with sodium sulfate. So lead nitrate react with sodium sulfate to form a white precipitate of lead sulfate plus sodium nitrate. So sodium nitrate is the colorless solution, and the white precipitate is this, the solid aqueous. We are asked to write the ionic equation. I've just written the overall equation, chemical equation. So, but we were asked to write ionic equation. So to write ionic equation, we are writing the ions that are forming the solid only. So directly we can write the ionic equation by writing the ions that form the solid. So let me write it down here, or even here. Let me write it here. So lead have sulfate, therefore we start with lead 2 positive aqueous plus the sulfate 2 minus aqueous, which are going to form lead sulfate, and that is the ionic equation for the formation of the white precipitate. Starting with the zinc metal, describe how a pure sample of zinc sulfate crystals may be formed. We have done that. I want to talk about these terms here. Deliquescence. We have a deliquescent substance and then the process of deliquescence. Deliquescence is a process, and then a deliquescent is a substance, is a salt, a substance. Now, what is a deliquescent substance? A deliquescent substance or a salt is a substance that when exposed to the atmosphere, it absorbs a lot of water from the atmosphere, forming a solution. That one is a deliquescent substance. But the process of absorbing so much water from the atmosphere to form a solution by a deliquescent substance is called deliquescence. So deliquescence is a process, but a deliquescent is a substance. Mark that. So define the following terms. If it is a deliquescence, you must say deliquescence is a process where a deliquescent substance absorbs so much water from the atmosphere and then it forms a solution. The other term that is not here is the hygroscopy. Hygroscopy and hygroscopic. Hygroscopy and hygroscopic. Hygroscopic is a substance, hygroscopic substance or a salt is a salt that when exposed to the atmosphere, it absorbs water from the atmosphere, but it does not form the solution. The difference between an hygroscopic salt and a deliquescent salt is that hygroscopic will absorb water but does not form a solution. Deliquescent will absorb a lot of water and form a solution. So the process where an hygroscopic substance absorbs water from the atmosphere but does not form the solution is called hygroscopy. So hygroscopy is a process. A process where a substance absorbs water from the atmosphere but does not form a solution is called hygroscopy. Finally, is a fluorescent substance. A fluorescent substance, these are substances which contain water of crystallization. So when they are exposed to the atmosphere, they lose their water of crystallization to the atmosphere. So those substances are called a fluorescent substance. These are substances when exposed to the atmosphere, they lose their water of crystallization. So the process of losing water to the atmosphere, the process where as an efflorescent substance loses its water of crystallization is called efflorescence. Efflorescence is the process where an efflorescent substance loses water of crystallization to the atmosphere. So it is important to know the examples of hygroscopic substances efflorescent and deliquescent substance. It is important you know examples in each of these salts.